Alright, hello, my name is Thomas Porter, and this is my part of the Group 4 project. The scene I will be analyzing is from the movie Home Alone 2, Lost in New York. The scene exactly is Harry Lime, one of the burglars, intrudes the house and sets his head on fire. I'll play that clip right here so you can see it. Now, when he sets his head on fire accidentally via blowtorch, he searches for water to put it out, and his choice is to go to a toilet filled with white gasoline. White gas is used in lamps, camping lamps, and camping stoves. And as you can see here, when Harry puts his head, boom, there is an explosion which lights up the entire house, as you can see here. And what I'm going to do is disprove this using chemistry. Okay, now we know that white gas was used because in the preparation of this, in this scene right here, we see the boy, not here but right next, almost, and here we go. Okay, so here the boy is using white gas, which is a flammable liquid, and when it's burning, it creates a combustion reaction. Now, when this combustion occurs, it occurs when a hydrocarbon reacts with oxygen to produce carbon dioxide and water. In a more general sense, combustion involves a reaction between any combustible material and an oxidizer. This is white gas being lit right here. This is a Darwin candidate, so please do not try this at home. He is lighting white gas on his driveway, and so this is what it looks like when white gas is lit. In order for the explosion as seen in this scene to occur, the combustion would have to happen so quickly, and it would just need about probably 10 times as much white gas as was used. Not to mention the white gas would have been diluted by the toilet bowl, but that's another discussion. Yeah, that's all.
So, the scene I chose was when Marv sent Harry flying into the air and he landed on a car, but I'm just analyzing, can Marv actually send Harry that high? And I use the equation G P E equals M G H. Alright, well, you're just going to bear with me on the writing. GPE is gravitational potential energy, M is the mass, G is gravity, which is a constant, so 9.8, and height is given, it's the height. And using this equation, I found out the amount of joules Marv can give or can transfer over to Harry with his height is only 1,715.5 joules. So obviously not very much. And I found out their height and weight just from the internet. Just look it up. And then I had to estimate the height that he was sent and all that because it doesn't give it to you. And then I also found out for Harry, the height that he was sent, because I estimated, was 5 meters. For the height to send him 5 meters, he would need to be given 3,998.4 joules, which obviously Marv did not supply since he only supplied 1,715.5. And using that, I was able to say that if he did in fact fly 5 meters in the air, the math would be off by 2.4 meters, which is obviously not even close. So there is no way that can happen in any situation, because that's even being lenient with the the forces, such as energy lost from the heat or air resistance. So, using that for the science of this scene, it's a zero because it didn't really give any real science. But for the movie, yeah, there's a bunch of fake stuff in there. You can give it a 6.
Kevin's house, and he is defending the house. And in this scene, Marv is covered with a lot of glue and paint that he had dumped on him, and this includes other sticky substances that are just not appealing to have on your body. He finds a sink within the vicinity in order to clean himself off, um, but little does he know that Kevin has hooked up an arc welder to the handles of the sink, and this causes Marv to become electrocuted and become burned down to a skeleton for a brief second. However, this scene is not entirely accurate. For example, an arc welder would be used to create heat due to the electrical energy passing from a high resistance area to a low resistance area. This would mean that the impact on Marv would be an arc burn. This type of impact can burn hot enough to melt metal. In the case of the movie, Marv would have had his clothes ignited or been thrown back by the pressure wave that can be released on impact. However, in the scene, he is met with injuries that would most likely relate to a high voltage burn. This is not an impact of the arc welder shown, as you can see in the picture shown on the screen. Even if Marv received a high voltage burn, he would not have been burned down to his skeleton. The impacts of this type of burn are strictly internal, the most severe being damage to body tissue and critical organs. Moving on to another imperfection of the scene is that Marv is burned down to being just a skeleton. However, soon after, less than 6 seconds, all of his skin and body tissue grows back. It's estimated that dead or damaged skin takes 27 days to grow back. This is most likely dealing with the top layer of skin, or the epidermis. Marv loses not only his epidermis, but also his dermis, hypodermis, blood vessels, and hair follicles. Yet somehow his body manages to regrow all these layers of skin in under 6 seconds. This is not to mention the loss of his eyes, face, and neck muscles, and pharynx, all of which would need to be replaced with artificial replacements or irreplaceable. Acquire these body parts is a lot longer than 6 seconds of time. In conclusion, I think that this scene is extremely inaccurate when dealing with the sciences.
My name is Caitlin Johnson, and I'll be analyzing the scientific feasibility of this scene from Home Alone 2.
Uh-oh.
I study IV biology, and in order to fulfill the requirements of this Group 4 project, I'll be talking about the biological feasibility that the man from this scene could have survived after having the cement bag fall from such a height directly onto his head. In a multi-story building, the typical ceiling-to-floor height is approximately 13 feet. In this video, you can see that the bag of cement is falling from the floor of the second story to the floor of the basement, which would be approximately 26 feet in total. What I'd like to call attention to here is that the bag of cement appears to have a label of 100 pounds on the outside. So in this scenario, we're having a 100-pound solid object falling for approximately 21 feet, if you subtract the height of the man being hit, and falling directly onto a man's head. In order to determine the true anatomical impact on this man's skull, neck, and spinal cord, I'm going to have to use a little bit of physics first. In order to determine the total energy that the bag had at impact, I used the following formulas. So I started out with the force of gravity, G, which equals 9.8 meters per second squared. Therefore, the energy at impact equals mass times G times height. And our mass at 100 pounds converts into 45.35 kilograms. You multiply that by the force of gravity, 9.8 meters per second squared. Multiply that by the height, which over 2 stories was 26 feet. Subtract the average height of the man, get approximately 21 feet. And therefore the total energy imposed upon that man's neck was approximately 9,333.03 joules of energy. It is the general consensus that approximately 1,000 to 1,250 foot-pounds of torque is needed to break a man's neck, and when you convert that into joules, you get approximately 1,600 to 1,700 joules. And as we calculated earlier, the amount of energy exerted upon Marv's neck was approximately 9,333 joules, which is significantly larger. And for that amount of energy to have been exerted upon his skull, it would have smashed his skull entirely, broken or snapped his spinal cord in half, and he would have undoubtedly died from the impact. Based on the knowledge that I have from my IB biology class, I'm going to have to say that this scene from the movie is completely scientifically unrealistic. Biologically, the human body would not be able to sustain this kind of damage, so I'm going to have to say that it is fake.